All right, 9.3, adding fractions with unlike denominators. So today I'll show you this strategy where you're finding a common denominator, not using the fraction strips. If you still want to use those to help you, you can, but I will show you sort of a more efficient way that'll work if you don't have strips or if the strips you have don't have the denominator in the problem. So hopefully by the end you'll feel pretty good about it. It's a similar process for subtracting and adding and subtracting mixed numbers. So if you feel like 80% after today, like you'll have more practice of doing a very similar process. So the problem. Paloma's mother made 2 pans of snacks. She will put what is left into 1 pan. What fraction of 1 pan is left? So if we think about how could I write an equation? What operation am I doing? Well, I'm combining them. So that is adding, which hopefully you realize because, right, this lesson is about adding. 1/6 plus 4/9 equals the total combined. So it does matter that the pans are the same size as far as combining the fractions. First we need to find a common denominator so that the pieces are the same size. Because if I say, oh, well, there's 5 pieces, well, how big are those pieces? Are they 6? Are they 9? Are they something else? They're both. Like, how do we do that? So I'm going to open up another sheet and show you how I would write it and walk you through the steps. So the first step on your page on your notes is to find a multiple that is the same for both denominators. Now, I find it's easier to write them vertically. Even if the problem gives them to you horizontally, I like to rewrite them on top of each other. So now I think about my 2 denominators. What is a multiple of each number that's the same? So if I have 6, 12, 18, 27, you can look at your chart to help you do this. Not 27, sorry, 24, etc. And then I have 9, 18. Oh, look! 18 is a multiple that is the same for both denominators. So that's going to be my new denominator. Now I'm going to rewrite the fractions. I'm going to find equivalent fractions by multiplying. So multiplying will go on your notes. So I think, okay, what do I multiply by here? Well, it's the 3rd multiple, so I multiply by 3. So I get 3 as my new denominator, because 1 times 3 is 3. Down here, I multiplied by 2. I take my numerator times 2 to get my new numerator. I might have said it backwards up on the first one. So then I have my new numerator. Then the next step is to simply add the fractions. 3/18 plus 8/18, I add the numerators to get 11. The denominator just tells me how big the pieces are. So I'd say, okay, it's 11/18. Now the last step, number 4, says you can fill in rewrite if necessary. Rewrite. And that'll happen if I get an improper fraction sometimes. I'll just have to change it to a mixed number. This one I do not. Or I might have to simplify it. This one I also do not have to simplify. Okay? So, hopefully that makes sense. I just want to see, I think we have a picture of both to help you see. They're just writing the same things. Okay, so 11/18 of the pan. Okay, I thought they might combine it, but they did not. So let's do some practice. I'll do one more, show you, and then I'll have you practice it and see if you can get it. All right, 2/3 plus 3/4. Oop, wrong problem. Or wrong one. 2/3 plus 3/4. So step 1 is we find a common multiple of both denominators. So if I have 3, 6, 9, 12. And if you stop and you realize, oh, 12 is a multiple of 4 as well, you don't necessarily have to write more. You might not realize it, so you might want to write like 5 of them just so that you have enough. If you didn't write enough, you can always go back and add more. So 12 is a common multiple. It's actually called the least common multiple because it's the smallest one that they have in common. So this one I'm going to do times 4 and times 4, so I get 8 times 3 times 3, I get 9. So I add my numerators and I get 17/12. This is an example of when I'd have to rewrite. 12/12 is 1 whole. I still have 5 more 12ths, so I get 1 5/12 as my answer. Okay, let's do another one and I'll have you try this one. All right, so this one I'm just gonna, I know they asked a different question. I'm gonna have you just try 1/6 plus 3/8. Remember, if you're not sure, you can always just guess and I'll explain it in a minute. But if you're feeling like you sort of got it, give it a try. You get it? If we have 1/6 plus 3/8. Notice again how I write them vertically. It does take some space, so make sure you have the space. You can either use your note paper, you can use a whiteboard, I can get your scratch paper, your math notebook, whatever. So 6, 12, 18, 24. I'll make sure to not write them wrong this time. This is why knowing your facts, being able to count by numbers is really helpful. Ooh, 24 is a multiple of both. So what do I multiply by? 6 times 4 equals 24. So I'm multiplying by 4 on top as well. Whatever I multiply by the bottom, I multiply by the top. 4 24ths. So remember that's equivalent to this. Times 3 times 3. So I get 9. Add my numerators and I get 13/24. All right, let's do one more. And if you still need help beyond that, no problem. All right, 3/5 plus 1/4. 3/5 plus 1/4. So 5, 10, 15. And again, if you just know in your head what a common multiple is, that is okay. You don't have to write them out. But I know not all of you do, so I'm showing you a process you can use. 20 is both. Think, okay, multiplied by 4. Notice in this case, we're multiplying by the opposite denominator. That happens sometimes. Doesn't always happen. It will always work, but sometimes there's a smaller one, and then I don't have to simplify as much. So then I get 17/20. Don't need to simplify, don't need to rewrite it. One thing I wanted to point out, if I have something like 2/8 and 1/4, I could just use 8ths and keep that one the same. And then I'm just multiplying by 1 or keeping it the same. Sometimes that happens where if one of them is a multiple of the other one, you can use one of the denominators you already have. If you have more questions, if you need more help, don't hesitate to ask. Good luck.